Hi everybody and welcome. Today we're going to be looking at doing division of polynomials. So we're going to be looking at two different methods, specifically long division and synthetic division. So our goal after watching this video, we'll be able to do polynomial division problems using both synthetic and long division. So first off, these are pretty complicated and longer processes that can be a little bit confusing sometimes. You might ask, so where does this come up? Like, why are we ever going to need to use these things? So big things that we want to take a look at, and actually an example that came up within the last few years actually was the Mars rover. So it has something to do with like the camera, the solar platform to see how much energy they could get, and sometimes you'll find yourself in a situation where you actually don't know like the length and width that you're dividing by. So there's going to be some variables involved. So if you're dividing with unknowns and you have multiple terms in those unknowns, that's where we're going to see division coming in. So this was a division problem that NASA had to do, and it was an example they were looking at, I think specifically up here, it was like this camera in the top of it to see if they could get some extra solar, I think, to keep one of those Mars rovers going. And they knew, again, generally about the total area, actually, so I misspoke there. So they knew the total area of the top of that platform. They also knew how wide it was, but they did not know the length. And they needed to do that length calculation to get an accurate projection, and we see there a real-world example of how we can do that. So right now, looking at this, might not know what to do, but we're going to have two different methods that we can go through and use to solve for division. So the first one that we're going to do is some standard long division. You might see it kind of mirror long division that we might have learned in grade school doing the arithmetic. So again, I'll write this on top. This is a long division example. So important things to note in long division, we do have to put the terms in descending order, and we're not allowed to skip even if the question does skip. So here we go from a second degree to a first degree to a constant. So there's no skipping, so don't need to worry about that. So what we can do is inside of the house, we are going to put down a squared minus 2a minus 15. And on the outside of the house, we'll put our a minus 5 term here. All right, so our first job is we need to make sure that our a squared cancels out. So the way that we do that is we have to have our first term match that term. So if we do the a times a, we'll get, and again, show us what we're doing here. So we're multiplying this times this. And when we do that, we're going to get a squared minus 5a. So we're going to subtract all of that like we were doing yesterday. And what we're going to see is, again, we'll get 0 for our a squared term, which we have to do, which is good. So we did that. And then secondly, we're going to get a positive 3a here. Again, when we subtract that negative 5, it'll turn into a positive 5. And then 5 minus 2 gets us that positive 3a. Next, we can bring down our minus 15. Okay, so next term, we have to get a to match 3a. So we're going to multiply each piece of that by positive 3. So we'll end up with 3a minus 15. And again, we are going to subtract this. So we'll end up with 0 a's. And we'll see that negative 15 will turn positive again, plus 0. If there is anything left after this step, that would be our remainder. And anything for our remainder would go over that a minus 5. So here, 0 divided by a minus 5 is just 0, so we need to worry about that. So actually our whole final answer, no remainder here, is just a plus 3. So long division, we're just lining these terms up, and we are making sure that that outside term can go in evenly. So a setup for the next question would be x squared minus 5x plus 3. On the outside, we have x plus 3. And now it's our job, again, just like we were doing, to match up the first term, then match up to the second term, then match up to the third term. One thing I would say to caution you and to be careful about, I know we're always talking about this, we are subtracting, so be careful of those negatives when you're going through and subtracting. All right, long division time. So this gets a little bit more complicated. Going on to our, Going on to our next example with synthetic. So I'll write that on top. So synthetic, I think it's faster. It can be a little bit confusing though. So we are going to have to know how to do both of these for our assessment. So if you feel more comfortable with one, that's amazing. But make sure again that we are doing these questions using synthetic, because we will be evaluated on can we or can we not do synthetic. All right, so how synthetic works is it's actually very similar. So we do need to list out our terms in descending order of degrees. So starting off with our, x cubed, our x squared. There is no x here, so we actually have to change this to look like, represent that 0x term. So we're not allowed to just not have that 0x term there. And the difference with synthetic is actually we don't write the variables. So that's why it's super important to have that 0x there. Again, can't skip one. So we just write the coefficients or the numbers in front of the variables. So we write down the 2, the 5, the 0, and the 9. Second, the thing that we're dividing by, that x plus 3, we take the constant there and we do the opposite of it. So we put a -3 in right there. So that goes in our top corner, and then now it's our job to go through and evaluate this question. So synthetic's a little bit weird. There's some steps to follow. So again, the setup is the most important thing. Make sure we have the 2, 5, 0, and 9, and then we have the opposite of that 3 there. Our next step, and I'll do this in a different color, is we actually just bring the first number directly down. So it's always a 2. And then we just kind of follow some procedures and we make our way to the end of the question. So we're going to take the 2 and we're going to multiply it by -3. And we're going to put that answer of -6 right here. And then we do 5 minus 6 to get us -1. And then again, we're going to take our -1 now, and we're going to multiply that by -3. And we're going to get an answer of +3. 0 plus 3 gets us 3. You can probably guess now we're going to do 3 times -3. That's going to get us -9. 9 minus 9 gets us an answer of 0. Okay, so we have our answer here. It's actually 2, -1, 3, and 0. A little bit weird, a little bit confusing, but work your way backwards. This is our remainder, which we don't have any for that. This is our constant, so just our number. This is x to the first power, and this is x to the second power. So it's always going to work up in that order. So it'll go remainder, constant, just the variable, variable squared, and then if we had more terms, it'd keep going from that. So our final answer to this question is 2x squared minus 1x plus 3 with a remainder of 0 over x plus 3, or just 0. We don't even have to write that last part. So our final answer here, 2x squared minus 1x plus 3 is our answer to this synthetic division problem. So if you're someone that can get caught up with variables and all the powers and all those things, and you just want to focus on the numbers, synthetic can be a really useful strategy. And also it's fast. I prefer using this. Again, I think it's pretty quick, and it's a really good way to go through a question following some procedures. A quick note about synthetic: in order to do it, what you divide by does have to be in that just x term first form. So we can't have any numbers in front of x. It has to be just x there. All right, so I know synthetic is a little bit confusing, so we're going to go through one more example here. We'll do the setup and then leave us some space to practice and see how we do going through it. So look at these here: x squared, x to the third power, x squared, x to the first followed by a constant. So that's perfect. We don't have to add any terms like we did up top. So we're left with 1, -4, +6, -4. Our number on the outside is not -2, but +2. Again, we're taking this term right here. We change it to the opposite power. And then now we just go through and we work through the example. And again, these are fast. So we'll bring down the 1, multiply 1 times 2 to get 2. -4 and +2 get us -2. Times 2 gets us -4. So we get an answer of +2 there. And then 2 times 2 is 4. 4 minus 4 is 0. So we end up with an answer of, that's our remainder, which is 0, which is nice. It divides in evenly. Next one is our constant. This is an x term. This is our x squared term. So our final answer to this division problem, see how fast that was compared to long division? We get x squared minus 2x plus 2. So practice writing these out. We will do some more examples in class. They get a little bit complicated, but glad that we could see a few examples of synthetic, a few examples of long division. Again, we will need to know how to do both of them, so important to practice both. And thanks for tuning in, everybody. Any questions, as always, feel free to reach out, message, email, any of those things, and I'll get